Hi everyone, welcome to AI Camp on Air. Today we're going to talk about TensorFlow ecosystem and tooling, but I'll give you a quick introduction to the community. So we're AI Camp, and our mission is to make AI available to all developers. What this includes is that we want to learn and practice AI from anywhere at any time, and we do this through, currently at the moment, webinars, live webinars, and live workshops through webinars. And we host around 15 courses in different countries with around 50 cities in the world. And we have a network of over 100,000 developers. So we're a truly global community. And what we kind of, our unique kind of area and specialism is that we are all technical people at heart. So we aim to bring those technical skills that we already have into the AI space and understand how to automate and operationalize machine learning techniques. I'm Christina. I'm going to be your host for today, and I'm the London community lead for AI Camp. And today we're going to talk about TensorFlow ecosystem and tooling. So in order to program great apps, software developers need not only a good programming language, but also great tooling. And for ML researchers and engineers, the situation is no different. So in this talk, and we have Gus, who's kindly come to give us a talk on TensorFlow and the tooling available. And we're going to go over some of those tools and libraries within the TensorFlow ecosystem that will make your life more easier and productive. And these tools are stuff like TF Hub, TensorBoard, and Colab. So Luis, or as he likes to be known, is called Gus, and he's a TensorFlow developer advocate at Google. He's worked in multiple software engineering roles, and he's going to give the talk today. So if that's all right, I'm going to hand over to you, Gus.
Yes.
Perfect.
Let me just share my screen real fast here. Oh man. Give me just one sec. Here it is. Is it okay? Can you see it? Nice. So, hello everyone. Good morning, good afternoon, good evening for, I don't know where you are. Today I'd like to talk a little bit about TensorFlow tooling and how to make your ML journey easier. And we can do some parallels with regular software development to make that helped me in the beginning to understand the tooling available and how to use them properly. As Christina kindly said, I'm from the TensorFlow DevRel team. My job is to make TensorFlow easier for everyone, more accessible, to explain the tooling better, to bring new developments to the community and to everyone around. So let's hope I can do a good job on that today. So let's start by, for those of you that are software developers or were software developers before becoming data scientists or ML engineers, I don't know in which stage you are right now, but for software development, we have some specific needs when we want to solve a problem. And I want to try to imagine your job as a software developer without a proper IDE or without proper support libraries or even without a debugger. So if you remember all your software development, if you did try to do that on the most basic text editor without any library from anyone, just do everything from scratch by hand and without a debugger. That would make your life way harder. You would take longer to solve anything. Even if you need just to print a number in the screen, do anything would be like super, super hard. And when we transport this to the machine learning world, we have the same problems, right? We need a proper IDE and we need support libraries to help you with that. And of course, it changes a little bit exactly what we mean by support libraries or libraries in general. And we also need a debugger to understand the values. And I guess I would say that the needs on the machine learning world are maybe, we have the same needs, but some of them are more drastic. For example, if you think about the debugger, if you're training a model with 1 million images, debugging that like line by line as we did in the past doesn't make any sense whatsoever, because you're not going to see anything. It takes like hours to get somewhere. So a debugger has to be smarter on that side. So how do you do those things? So let's start by IDEs. And of course, the other part we need to remember is that we have to collaborate with our peers, because working with others is better. It's fun. When we talk about TensorFlow, everyone knows TensorFlow is the framework to do machine learning in an easy way. But it's more than just a library that you can do gradient descent, or that you can do all the optimizations and all those things that we read. It's way more than that. And it's a complete framework to do from experimentation to deploying to production, to deploying to mobile, to deploying to the web, to deploy anywhere. We have the whole framework of everything you need. And I'm going to go over 3 specific tooling today, so that you see that, to see more possibilities, right? Let's start with the IDE. So if you do machine learning, I guess you've played already with Jupyter notebooks. That's usually where people start to try things, starts to play around with how to do a model, how to do a simple neural network, or some linear regression. We have Colab in Google. It's the idea of a Jupyter notebook hosted on cloud for you. You don't need to worry about basically anything. You just open and start playing around with it. You can just put all your Python code. You can install packages. You can install binaries. You can do basically anything you would do in your own machine. The only advantage is you open the notebook, start playing, have your results, and when you don't want anymore, you just close the tab, and it's going to, you don't need to worry about turning off the machine. You don't need to worry about, you don't need to worry in the beginning to create a proper machine with your own VM, and you don't need to worry about anything. If you're just experimenting, that's great. And the Colab environment is, of course, as Jupyter Notebook is completely on the web. You don't need to install anything in your machine. So that's basically a great IDE. If we think about how it started, Jupyter Notebooks already exist in the past for multiple other things, even before machine learning was super popular. And we start using internally, but as you can imagine, the internal use in Google is already advanced, and people just want to experiment with things. So we created this service internally to any researcher could just play around with their code, with their model, have some results, and don't worry about the piping behind it. So because this is from the machine learning perspective, that's not where your work is, right? Your work is playing with the model. So we did all of this internally, and when we see it was how that was good for us, of course we created the product for everyone. It's open. So what do you get when you play with Colab? We have already pre-warmed VMs with GPU sometimes. It comes already with a lot of pre-installed packages, like for example TensorFlow, it's always there. But it has some resource limits, of course, given all I said here, you can play with all of that for free. The Colab, the machines will be reclaimed if you are not using after a couple of hours. If you are using, there is also a limit. I don't remember exactly the number, maybe 12 hours. But the goal is for you to play around with it for learning something, for trying something new. But if you're going to do like your full research with millions of points of data or images or whatever you're playing with, so we would suggest you try Colab on your own VM using GCP, Google Cloud Platform, or you can use Jupyter Notebook on your own machine, of course. But if you want to play around with Colab, it's there for you. We have also Colab Pro, which gives you the best GPUs possible. We give longer runtimes and more memory, but this is only available in the US as of now. And if you're here in the UK or in Europe in general, you don't have access to that. So if you need to use Colab in longer ways, you should use with your Google Cloud Platform account. Then you can create a VM and start a Colab inside GCP, and then it's your own VM. You can do whatever you want. You can configure any way you want. But Colab Pro, we are trying to bring to every country, so whenever it's available in Europe, we'll announce it, definitely. So this is a great tooling, first for learning. So if you start learning TensorFlow anywhere, I'm pretty sure you've seen these Colab links already I want to do this image classification, I want to do this object detection. You just click. Sorry, my desk's falling apart. Sorry. Then if you've seen those Colab links everywhere, so you can just easily click, connect, and you're playing already. You have zero friction to start learning something. So Colab is the idea. It's not exactly part of TensorFlow, but it's part of the tooling that you can use to play with TensorFlow. Let's think about another challenge now. If you're playing with machine learning a lot, one thing that comes to you a lot is our papers, right? So people are writing papers and publishing them non-stop, and it's almost impossible to keep up with all of them because there's a lot of them. But then comes the next challenge. You find a paper that you really like, and now you want to play with that model because it does something cool, and you want to see how it does. You want to see quality of the results. You want to understand more of it. And this is a problem because sometimes the code's available on a code repository somewhere, and then you have the link. Sometimes the model is there. Sometimes there's a script to download the model that downloads the model from somewhere. Sometimes you have to retrain the model yourself. They give you the code for the model, but don't give you a checkpoint or a saved model for that. So it starts to become harder and harder, and sometimes the way of using the model is not really well documented. You have access to it, but you have to read multiple files of Python code to understand how to use the model. And then you start to come up with more questions, aside from how do I use this model? Is it a fair model? Can I use this on my environment? What are the drawbacks of this model? Is this code repository with the latest version of the paper, or is it somewhere else? And so it starts to get complicated really fast. And this is a problem I faced multiple times when I was playing with TensorFlow in the past, because I want to play with a model, and then if you don't have like a lot of time to go over code from other people and understand exactly what they're doing, it's going to be like it's hard, right? Given that we have a solution for that, that's TensorFlow Hub, tfhub.dev. You can go play around with that. And tfhub.dev, what it does, it's a repository for models. So anyone can publish their own model, and it will be available for anyone else to download, to play around with it. So this is an easier way to find models to solve your problem. TensorFlow Hub today has models to deal with image, text, of course, video, audio. So if you want to play with any of those, in any of those problem space, you have models to help you with that. We have more than 1,000 models, and we are increasing every day. There's more people publishing. And let me do, so the cool thing about the models is whenever you, of course, TensorFlow Hub, there has a search page. Let me just go back here. So there's a search bar. You search for whatever term, like if you want to search for object detection, if you want to search for, I don't know, sound, if you want to search for a specific model name, BERT, if you want to search for specific architecture, data set, you can search for all of those things. Given you find a model, some of those, not all of them, because that depends on the publisher, you have a visualizer right there before anything. So you see the description of the model name and already a visualizer of the results. So we have some new ones like these plant diseases, the food one. You can just drag an image and see the results. That's as easy as it is. And if you want to play with the model, you have a link to download it. You have, sorry, this is already an old page. We updated the visuals, but it's basically the same idea. So you have already, you have the description of the model. You have how to do the inputs, what are the expected outputs. We have the link to a Colab notebook where you can play with the model right there. You can download the model, of course. And we have also, we show already other formats of the model. If you want to, here in the example, you have the saved model, which is for serving or playing with Colab, or if you want to deploy this on the web, on the browser, you have the JS versions. I'm going to talk a little bit more about this later, but so you have all this information. Of course, all the description of inputs and outputs and everything, that depends on the publisher. The publisher has to have the will to write all this information. We try to talk to them as much as possible whenever they're publishing to, hey, maybe you should add a section explaining A, B, and C. And most of them do, because that's part of everyone's interest to make the model as easy to access as possible. So let's see some examples of how you would use TF Hub on your flow, for example. Let's start by a very dear to me example. It's style transfer. So style transfer is basically you have two images, a content image and a style image. So here the content is an image of a dog, and style image is a painting from someone, right? From someone famous. And what style transfer does, it applies the style to the content image. So it makes the content image seems like it was painted by the same person that painted the style image somehow, right? It's a transformation. And we have this, of course, this model on TensorFlow Hub, and it's, let's see how hard it is to use it. First of all, what you need the link to the model. So here we have the arbitrary image stylization from the Magenta team on TensorFlow Hub. This link is very interesting. If you copy this link right now and you paste this on a browser, you are going to be directed to the documentation of this model. Right now, you can see all the documentation of it. If you use this as a handle for Hub, it will find this model and download that for you, and then you can use it. So here, you just do import TensorFlow Hub. Of course, we have a library, and you give the handle to the library, and load it. So from here, the third line Hub module already, we will have the fully loaded model for you, right? And it's cached. You can keep doing this like 10 times in a row. It's the first time it be cached, you won't download anything else after that. And then you just get this module, and you just give the content image and the style image, and it will give you the stylized image that would be something like that. And that's it. That's how you use the TensorFlow Hub library. You just need the handle and to load the model. Basically, is that. So that makes using machine learning way easier, right? You don't need to download anything yourself. You don't need to do all the changing inputs and outputs from some transformations some people require. You just use the model as it was created, as it was expected. And of course, all this documentation is available on the page. So that's very easy. I left a link there for style transfer. If you want to learn more, you can follow that. We have also some tutorials. I'm going to show the link later to use Hub. So this is for image, right? Image is cool and all, but people like to talk about text. And text, there are multiple parts of playing machine learning with text. And one of them is whenever you do machine learning, a neural network, you don't give text directly to the machine because it doesn't know how to deal with that, right? So what we do, usually we use something called embeddings, like word embeddings, which is a way to explain to the machine in a multidimensional space what is the value of a word, let's say like that, right? I know it's not the perfect definition, but it's how to explain to a machine how words are close to each other, how they connect to each other. So embedding is similar like that. And TensorFlow Hub has multiple embeddings in multiple languages that you can use. We have one here specifically is the Genius Swivel. It's not the best one, and it's not the best one because if you see on the handle there, there's a 20 gene that's for 20 dimensions. So if you imagine like we put these words in 20 dimensions in space. It's very hard to imagine 20 dimensions, but try. So these are not many, right? So 20 is very, very few, but this is just for playing around with this model. You have like for hundreds of dimensions, models with 100 dimensions also on Hub, you just find that. Same thing here, you have the handle, we have TensorFlow Hub library imported, but here we are going to do something different. We are going to use this model as part of our bigger model. In the previous example, we were using directly the model as is. Here, we are going to use this as a Keras layer. So for all of you, if you play with TensorFlow, you've seen TensorFlow 2.0, where Keras is our base suggested API. Here, we're going to create a neural network using Keras, the Keras API. And one of the layers will be an embedding for text. So we are going to do a sentiment analysis here. And as you can see, the hub lines are like, there are 3 lines there, like the importing TensorFlow Hub, of course. the handle and loading the keras layer. From there, we are going to create a sequential model which has an input layer, which is the embedding. It will receive a string, as you can see in the definition, with any size. And then we are adding two dense layers, one with 16 neurons, one for 1 neuron, that will give the positive or negative result of the sentence, if it's a positive sentence or if it's a negative sentence. And then we're going to do a training here for 20 epochs, and that's it. We are going to have a model. When we finish there, this model can be used to do sentiment analysis. That's it. That's basically that. Also, same thing, we have link there if you want to play around with this on from TensorFlow. And we are using embeddings here. You can do, of course, there are way other embeddings for other languages. There was publishing, I guess, 2 weeks ago, last week, one that's like more language agnostic, so you can do other things with that. There's a bunch of BERT models for language, so there's a lot of things you can play around on Hub for text. And if you want to go see much more examples for also video, for also audio, and more advanced, you can go directly to tensorflow.org/hub/tutorials. We're always adding new tutorials there, and with improving code and all of kind to make it easier and easier for you to take a look. Just to see how it works a little bit internally, so you know, here's a very simple use of Hub, right? We're loading another embedding here with, as you can see, with more dimensions. And we are going to just see the values of the words in the embeddings here, but doesn't matter what the code does, but what's happening behind. So behind the scenes, we have TensorFlow Hub library that will has all the assets there, and then you download it. When you do the load method, it will call our backend and download the model from there, do all the, of course, the verifications and stuff. It will download it locally for you to use directly, and it's going to be the cache. And then from there, you can, of course, you can define the cache here. It's a way you can define a system, an environment variable to define where this cache is going to be. So if you want to work with this directory later, on regular settings, you don't need to worry about where the model is. But if you want to download the model and, I don't know, convert it to TensorFlow Lite, for example, for whatever reason, if it's not converted yet, you will need where the model is. So that's why you would define that. And that's, you can see what we have the saved model, the variables, and the assets here in that were downloaded. So this is how it works in the behind the curtains. You don't need to worry about too much about that. And lately, we improved our search we are always improving search to make this part of the journey easier. We also put some filters to, if you want to find a TensorFlow.js model, TensorFlow Lite model, a Coral model, if you want to find a model that's TensorFlow 1 or TensorFlow 2, it has impact on how you use them. So you can filter for all of that, and the search is getting better every day. For TensorFlow Lite users, we added metadata, we added Android Studio integration, we added ML-Kit integration. There's a lot of new cool things that we're always improving. TensorFlow.js, same thing. We have all new models coming every day. And one important thing is anyone can contribute to Hub. If you have your own models, your research, if you want to contribute, you're more than welcome to do so. Last couple of weeks ago, some community were uploading multiple models. We are always working with them to make the process even easier. But the goal is it's not a Google repository. It's not a Google DeepMind repository. It's for everyone. So it makes easier for everyone to publish and to have access to these models, right? And if you want to publish, there's this URL here. I can share later on the Slack channel if you want, so you don't have to type it. And so just so it's this part would be for libraries, right? So if you want to, when you're playing with machine learning, sometimes you want just use a model, and a model can be seen as a black box, like a library. Oh, thanks for posting the link there in the Zoom. So it's a black box that I want to just use it. So TensorFlow Hub, TF Hub, makes your life way easier to do that. I've been in a world where it didn't exist, and not being the super advanced research was very hard to not understand how to use a model. So Hub helped a lot. and that's why I added here as one of the tooling. And let's go for debugging. So as I said in the beginning, debugging a machine learning model is, how do you do that, right? What can you do? Can you put a breakpoint? Does it make any sense to put a breakpoint at all? Do you want to read the logs, like all of them during training? Does it make any sense? Can you understand all of it if it's not your own code? Do you put a printf somewhere? Can you try to have a loop and see what's going on? And that's not exactly how you would do proper debugging on machine learning, right? On a bazillion of data. That's not how you do it. So how can we help with that? We have a tool called TensorBoard. And TensorBoard is a way to visualize your data, visualize your output, visualize your log, visualize the definition of your model, visualize everything with graph, with information, with summaries and all the statistics you might want, so that you can, while your model is even training, you can understand what's going on. You can, for example, look into TensorBoard visualization. You can see if there is some overfitting of your model already. You can see if there are classes that are not trained well for lack of data or for some kind of bias. You can do a lot of things on TensorBoard, and it's the good thing is that it's completely integrated with TensorFlow. So all you need is, when you are training your model, you just need to set the logging of your model properly, and then you have access to all of this. You don't need to write a specific something yourself by hand. You just define the logging directory, and things will work for you. And the good thing here, so I'm not going to go into too many details, because to understand all the details here, I would have to open TensorBoard, and that would take like at least a half hour. So, but the goal is you can see all the results of your model, and you can try to understand visually what's going on, and that helps a lot. The other thing you can do hyperparameter. You can see all the hyperparameters that were tried, and it will help you with finding the best hyperparameters. And how do you use that? How would you use TensorBoard? So first of all, you just define a callback. If you're doing a Keras model, you just define a callback and define the log directory, and you add this callback to the fit method of your model, and that's it. It will save everything that's needed on the proper directory. And then you can do something that's really cool, which is use TensorBoard directly inside your Colab. So these two lines are very interesting. If you didn't know about that, please take note. With that, you can have a cell that the output is TensorBoard. So you don't need to open another tab. If you want, you can do, of course. But if you want to have that on your notebook, you can just do it over there, and you can see all the results right there in the same place. Of course, Colab has even the free one, doesn't matter, has access to this. So this is a very nice integration that helps you be more productive in the environment. And the next good thing you can do with TensorBoard is, of course, when you have your results, you might want to share that with your friends, because working with friends is always nicer. And usually sharing a notebook like that back and forth works, but sometimes you want to share more information, and sharing with people, that's what makes all these products way better, right? So what we have to help you on that side, we have tensorboard.dev, where you can upload all your logs, and you can share these with anyone else that you want, and you can just do that for whatever reason. So if you're doing a research, if you want people to look into your data, you can just share on TensorBoard, and people just have the same TensorBoard access you had and see all the results you've got. So this makes life for other researchers easier to understand, to learn from your work if you want to share something. And so we had this model called Big Transfer that was published like in May, I guess, if I'm not wrong. So the model, there are a bunch of them because they're related to image, and they're related to size, right? So there's a bunch of sizes. So the model is on TensorFlow Hub, and the training logs is on TensorBoard. So if you, there's a link there, you can just search later. So we are using this to share research results and also to share the model with the community. If you want to just upload it from Colab, you can just just define a name and a description. You can just upload your logs directly to TensorBoard. TensorBoard.dev, and you can do that straight from your Colab, which makes your life easier. We have the same API, same visualization that you have on the TensorBoard that you install locally. You have the same. It's not exactly the same. We are missing some items, but we are always increasing the number of items that we show on TensorBoard.dev. And you, of course, from there you can share on social network, as our friend did here. You can just click and see the same results, right? So that makes showing your results something more, something easier for other people to verify, to learn from it. And you can just go to TensorBoard.dev and play around with that. And what I want you to learn today is to have a good journey doing machine learning, and you need proper tooling to support you, and you cannot do it all by yourself. And I would like to remind you and to remember that TensorFlow is not only a machine learning SDK. It's more than that, way more than that. It's a full framework that give you tooling to help in all the steps of your journey. So today we talk about Colab, we talk about TensorFlow Hub and TensorBoard, but we have way more tooling. We have TensorFlow Lite if you want to deploy on mobile devices or embedded devices. We have TensorFlow JS if you want to use to deploy on a browser or on a Node.js server. We have TFX if you want to have a full pipeline that deploys your model to production, and you are doing on a enterprise environment that you need to keep this happening all the time, and much more tooling than all of this. But we have everything that you might need for your work, no matter what step you are, what stage you are. And that's all I had to tell you today. Thank you. If you have any questions, I don't know if you have time for questions, but that's it. Thank you very much. Do we answer questions? How does it work?
Hi, thanks for that, Gus. Yeah, that was really great. And yeah, a super helpful overview of tfhub.dev, TensorBoard, and TensorBoard.dev. In terms of the Q&A, there's a tab at the bottom of the Zoom call, and we have a few questions that have been posted in there.
Okay, Q&A, yeah. How would you debug a Python code in Google Colab? I'll just answer, I'm not typing anything. So you don't debug properly with debugger stopping anything like that. When we talk about debugging in machine learning environment, is more looking at your data and how it's evolving with training. So it's you don't do. I don't really know exactly how to do debugging in a traditional sense of stopping on line whatever. On Colab, I don't know that, but if you want to do that from a machine learning perspective, we have TensorBoard that will help you with that. And I think that since this question might be earlier, that's why I didn't talk about TensorBoard at that time yet. Next one, how much flexibility is, oh no, thank you. How much flexibility is planned to install packages in Colab? Non-Google deep learning frameworks had no or limited support in Colab in the past. Is that changing? So I'll give you my personal experience, right? I need to install some audio-related tooling that are not Google-related. Some are open source, some are just free software, some are libraries, some are binaries, and I managed to install all of them. They all worked fine without any issues. So we're always improving there, of course, but today we have a very good compatibility, I guess, environment. So you can install a lot of things. I didn't have any problems installing anything so far, but I'm not saying that it's compatible with everything, right? I cannot tell you that. But as of now, all I did every time I try to install something, it worked fine. Of course, we don't put restrictions, right? It might be that if you want to try something and it doesn't work because maybe the library or binary depends on something that the VM below it doesn't have, right? So that might be the problem. But the idea is to be compatible with everything. Doesn't need to be Google or non-Google related. That's not like there's no filter on that, right? I hope it helps, Irina. Next one. Sorry. Can we upload models using PyTorch to TensorFlow Hub? Unfortunately not. It's only for TensorFlow models. And the problem is when you use the TF Hub library to load things, we depend a lot on the TensorFlow environment, right? So we cannot load PyTorch models there. So we only TensorFlow models as of today. And TensorFlow related like TensorFlow Lite, TensorFlow JS, and Coral. And, did I jump? I skipped one. Is TF Hub TensorBoard across other cloud platform Azure? Oh, I skipped this one, sorry. So TensorFlow Hub is a website by itself, so it's not related to any other cloud platforms. TensorBoard and works on should work on any of the other cloud platforms. There shouldn't be a problem because it's open source. You can just install from pip install and it would work. For Colab, I imagine it works, but I cannot say for sure. I know that Jupyter Notebooks works for other cloud platforms. You might have to install and do the VM management yourself, but it would work, right? So sorry for skipping your question. The problem is that keeps. How do I? Should I? Is there a command prompt?
I'm answering them, so they disappear from the top. So just focus on.
Yeah. I'll just answer all this in the top. Is there a command prompt or a cloud shell of some kind available in Colab? Is there a command prompt? So what you can do from Colab, I don't know if it's exactly what Avin is asking, but from Colab you can execute any command line you want. You just put an exclamation mark in the command line, and it will run as if you have an open command line on that VM. So you would be able to do apt get, you would be able to do ls, wget, anything. You can do any command line things. And if you have the cloud platform tooling installed, you would be able to do gcloud, whatever, right? So that's something you can do definitely from Colab. So Vin, answer. Nice. If implementing cutting research into a project, some of the research is actually written in PyTorch. Researchers seem to prefer them now. What is the approach and challenges one might face in implementing research into TensorFlow? Could you point me to the right way to avoid making time-consuming mistakes? I think TensorFlow will have a lot of tooling to help than PyTorch. So sorry for my ignorance. I'm not an expert on PyTorch, so it's very hard for me to say what's good, what's bad. From TensorFlow perspective, I think one thing that you can keep in mind is we use internally in Google. That's the main TensorFlow. That's the main machine learning framework we use internally. And as you can imagine, we have a lot of needs. So our tooling are in a way to solve our own needs before. So we build things that work and that are tested internally a lot. So we know what are the steps that all developers might need to get to where they want. So for example, we need to deploy on mobile devices. We have a library to help you with that. Need to do some pipeline and deploy in production and keep that environment safe with a pipeline that's running all the time. We have solution for that with TFX. So we have all the tooling to help you with more than just creating the model. Creating the model, as you said, for researchers might be easy. Maybe it was before TensorFlow 2. Now with TensorFlow 2, it's way easier to create models using the Keras API. So I would, of course, I would suggest TensorFlow, but I cannot say, I don't know much about PyTorch, so I cannot say too much about their framework. What I can say is that TensorFlow framework helps you a lot, and it's always evolving with new tooling. So that's a thing that I would say. I mark that as answer. Sorry. Can you please share a bit more info on how to productionize the code in TensorFlow? I can share briefly because to go to production, as you might think, it's not just, oh yeah, finish my model here, boom, put an API here, access from somewhere. It's definitely not like that. You have to worry about being able to have a model with good quality. Some people, most of the people should at least worry about if your model is fair in terms of, is it giving fair results for all kinds of inputs? Is this model, is the quality good? Is it performant? Is it fast enough? And so all of these things are very important. And when you train once, you have like one result, a saved model as a result, and you have to keep improving on that, right? So having data, cleaning data, training a model, looking to the quality of the model, quality of the data, comparing against previous models, all of this requires a lot of work, maybe much more work than creating a neural network with layers. That's way more work. And sometimes we oversee this because the cool thing is creating the model. But for enterprise or for people putting models in production, that's the tiny part, right? The rest of the pipelines in the DevOps work that comes with it, it's where the hard work might be. And to help you with that, sorry, I thought someone was that door. To help you with that, we have TensorFlow Extended that helps you create pipelines that can do all of this process, control this process and having steps on saving states on every step, so you can come back there and update something and see the results so far. It compares models for you automatically. It shows you the quality of your model, and you can create a full pipeline that can train, for example, every day, retrain the model and deploy to production if it's better. So you can do all of that with TensorFlow Extended. So this kind of tooling is, of course, for way more advanced users that are deploying production. And I definitely suggest to take a look because in the past I talked to people that when I presented them TFX, they said, "Oh my God, I was building that myself with a bunch of scripts." And you can do that, of course. I'm pretty sure anyone can do that. Any good developer would be able to do that. But that's not really your job, right? Your job is to put that into production, put your model. If you have to give support to your own framework with scripts and going over all the same mistakes we've gone already, it's way more work. So maybe just using TFX would make your life way easier. So that's what I would take a look to go to production. We have multiple collabs and guides on TensorFlow.org website to explain how to use TFX, all the components that I just mentioned for quality, for dealing with data, all of those. And we have also have a very good solution on Google Cloud Platform that uses TFX as the basis to do all this pipelining, loading data, working on the data, analyzing everything, model, testing the model, deploying all of this. We have all of this already available for you. So I would definitely suggest to take a look on TFX. And I'm marking this as answer live. No problem. Any tips for the TF certification? That's a good one because some friends of mine asked me the same thing. There are some guides of people that they just did all the tutorials on the TF.org, and they managed to pass, but that's not the best thing, I would say. The TensorFlow certification has a corpus of knowledge, I guess, on their website. I would go over there and understand. But I think if you are able to understand how TensorFlow datasets work, TensorFlow core, which is Keras, APIs, all of this work properly, you have a good chance. But the main tip is study all the content, be comfortable, and I'm pretty sure you can do that. You can pass, and I highly recommend that. Could you do a second session TFX, XLA, and less well-known tools? So for TFX, I could definitely do that. I would suggest my friend Robert to do that because he's. If you know TFX, you probably know Robert because there's a lot of videos of him talking about TFX on YouTube. I can definitely talk to Christine and Bill to get to him to maybe he could do a TFX talk. But if he's not available, I can also do that. There's no problem at all. Is there a common? No, this one I answered already. Going back to downloading models from published papers, do you have a recommendation to exploring a saved model PB file in working out the inputs. Yeah. So this is a challenge. I have this problem multiple times in terms of you get the model and then you have no idea how to use that at all. So one thing I use usually, there's an app called Netron, Netron, that shows you the graph definition of the model. So you can take a look on the input and output there, and so that helped me a lot to understand, oh, so the input should be something like this, and then you just play around with it. So sometimes you have to go into the code, and sometimes the researchers have like a test file that does the testing, so you can try to see what they are doing. But that depends, because it depends on what the researcher published on the code repository. And everyone does something different, right? They do what they think it's best, not exactly what everyone else is doing. So this is tricky. It's hard. It's hard. There is no easy solution there, aside the ones I told you. And I guess the best solution would be to try to find the model on TensorFlow Hub and see if it's there. Then you have a collab, and then it's easy. Otherwise, you have to go code, find the test file, and play around with it. That's a little bit tricky. And use the Netron app. There is a TensorFlow, but there's also TF. Oh, so there is TF Hub, but there's also TF datasets. Are these the same repository, or what is the distinction between the two? Oh, so Ben gave a good answer. TF Hub is part of the library. TF Hub can be uploaded. So there's it's a little bit different. So TensorFlow Hub, of course, is the repository for models, and it's only models today, right? We serve saved model. That's all we have. For TF datasets, it's if you want to have MNIST data, if you want to have IMDb reviews dataset, and then you can use those datasets that are hosted maybe on a Google Cloud bucket somewhere that I really don't know, but you don't need to worry either, because you just use the library to download it. You can use those data to train your own model, maybe using an embedding from TF Hub. So they're different things. So Hub is for models. TF datasets is mainly for the datasets that are available. There may be 30 or 40, I don't know. There's a bunch of these datasets are publicly available for you to play around with it. And also this TF dataset, if I'm not mistaken, also help you play with data on transforming, applying functions, maps and stuff like that on data. So they are different parts of the flow. You would play with your data first. When you have the full transformation, you can use a TensorFlow Hub model or your own model with the input you just prepared, right? So there are different parts of the puzzle. How does TensorBoard work with custom ML models? I don't know if I understand exactly the question. So if you're creating a model using TensorFlow, all your logs will be saved already in a format that the TensorBoard understands, right? So you don't need to change your log for that. You can add more logging capabilities. If you think your model has specific logging that you need to highlight somehow, there is an API for TensorBoard that you can create a callback that will write specific data for you, and you can show that on TensorBoard also, right? So you can have more, it's not like a custom model, but it's a custom data that you can show. So you can do that, so you can log more than just what's on the template, as far as I understand. Can we use AI flow for parameter tuning from inside any of these environments? Sorry, can we use AI flow for parameter? Sorry, I don't understand if you can, if Sri Hari, sorry, I don't know how to say your name, sorry for that. If you can just, I don't understand, I can try to answer if I understand better. What's the GPU in Colab equivalent? Oh, sorry, this one I don't know, because they keep changing. So the GPU available on Colab, I'm pretty sure it's not the top one. I'm almost 100%, not for the free one, right? But it's a good one. It's enough to play around with it. It's not going to be, oh, let me retrain BERT from zero. That's not what you're going to do there. But I don't know exactly which model it is, sorry. I don't have that information. I still wonder what this full framework means. So Rafa, so what I mean for full framework is when we play with machine learning, there are multiple pieces, and our goal might be to go from data to a model in production. And this model in production can be on any device, any environment. When I say full framework, is that TensorFlow can have tools to help you in every step of this journey, from playing with the data, to understanding the quality, to changing, to creating a pipeline of data for your model, to creating the model itself, right, which is TensorFlow is most known for, creating the neural network, to debugging this neural network, to using other people's model as part of yours, to like an embedding, to have this model be deployed for serving. We have TF serving for that, which is also a part of TFX. And we can also convert to mobile device. TensorFlow, so it's, most of your needs will be solved by one TensorFlow tool. That's what means full framework, I guess. It's a little bit abstract, I know, but it's from, if you are, one thing is, if you're trying to do machine learning on your company, that's going to be hard to find a question in terms of, yeah, but TensorFlow cannot help, doesn't have tooling to this part. We might have the tooling for that part, because we've solved this problem multiple times. Can you convert PyTorch to TensorFlow via ONX? Ooh. Sorry, everything jumped here. I know there was a, can you convert PyTorch to TFX using ONNX? Let me try to find that. Yes. Can you convert PyTorch to TensorFlow via ONNX to upload to Hub? Yes, you can. Some people did that. I know there are some compatibility issues when you convert. Sometimes it doesn't work for whatever reason. I'm not an expert, but you can do that if you'd like to. If there's a PyTorch model that you would like to have on Hub, please convert. If it's on a saved model format for the TensorFlow expected model, you can upload that to Hub if it's open source, of course, and that would be great. And the thing is, if it's on saved model format and you can load on TensorFlow, you probably can upload that to Hub and it will work fine. So that's basically it. So that would be, some people did that for. There was someone from the community that did something like that, but didn't convert exactly for TensorFlow. I guess it was for TensorFlow Lite and uploaded to Hub or something like that. So yes, you could do that, Brian. Would be great if you do. Please let me know. Does TFX help with pruning or other ways to reduce the model size? So for the tooling for pruning and for quantization, for all of those things, I don't have an answer right at the top of my mind if you can do that exactly. If there's any specific tooling, we have been working on having pipelines that does from data to TF Lite, right? So we go all the way to mobile. For those pipelines, you would need pruning, you would need quantization, you would need all of those things. So if it's not there, it might be in the plans to get there. We have, of course, the tooling to do all pruning. We have sorry, I forgot the name. There's an optimization, TensorFlow optimization toolkit or something like that to do pruning, to do quantization, to do these methods that will make your model smaller in size. So we have all those tools. I don't know if they're completely integrated on TFX. I don't have I'm not 100% sure on that. Do you have any other questions? Any on the top? I guess it's over, right? I guess answered all of them, or I'm not.
Yeah, thanks for that, Gus. I think you've covered most of them. And that was really, really helpful, especially the additional details you provided about TFX. And we'll definitely get in touch with your friend Rob to organize a session on that.
Yeah, of course, TFX is amazing.
So thanks everybody for joining. I have a few company or community-wide announcements to make. So basically we are quite jam-packed in terms of event scheduling for August. Please keep following us in terms of the Slack community and the emails that we send out. But I'm just going to mention a few of the events that we have. And one of them is a few summits that we're planning to run. Now, these are going to be one-day virtual events. And the aim of them is to bring developers, engineers from all over the world together to share in machine learning and engineering experiences, both in production, practical experiences, best practices, tools and frameworks. So covering all hosts of discussions around those areas. The structure of the day, firstly, the day is going to be the 14th of August, and the theme for the first session is ML Ops, so operationalizing machine learning solutions. So the structure of the day is that we have a block 1. This will be for the North America region, and that will be hosted from 10 a.m. to 4 p.m. Pacific time. And then block 2, so that's for the EMEA and APAC region, and that will be 1 a.m. to 7 a.m. Pacific time, but a more palatable 9 a.m. to 3 p.m. British summer time. So that's going to be on the 14th of August. Stay tuned for more details about that. And we have a really amazing speaker lineup for that session so far. Then we have 2 more loosely planned summits that will be taking place in September. One on the 3rd of September, and this is going to cover auto ML or automating ML. And September the 18th, and that will cover natural language processing. So that's the global summits that we have planned for the summertime. We're also hosting or thinking of hosting an ML paper club during August. These sessions are designed to engage developers in the kind of socio and political impacts of design decisions in machine learning. So that's from large-scale social media platforms to anything on bias in machine learning algorithms. We're hoping to get a really diverse kind of pool of researchers and practitioners involved with those. The format of those is likely to be around 1 hour, and they'll be hosted during the 12:30 to 1:30 lunch break in the British summertime. So both can be configurable for European and kind of Pacific Coast time. And what we're really looking for is a call for researchers and papers to discuss during those sessions. We aim for it to be kind of collaboratively decided, the reading list from the community and from kind of some of the community leads and what they would be really interested in speaking about. And then we have some more general requests from the community. So I'm the community lead for London, but we're always looking for more volunteers on our end to host more events. We have such a large community now, and we really want to put on events for you guys and discuss the kind of tooling that you're interested in, as well as more recent developments in the ML community space. And also, if any of you want to become speakers like Gus yourself, please reach out to us on the Slack. So I can share my screen again, just so we have that up, if that's okay.
Let me just say one last thing, Christina, very fast.
Yes.
So if again, thank you all everyone. If you want to reach out to me, you just Twitter @Gustema. You just ping me there. I would love to hear about any stories about TensorFlow Hub specifically. So yeah, that's it. Thank you, Christina, for having me. Sorry.
No worries. Let me just share my screen just so you guys have the Slack link and you can take it down and be engaged with the community after the session as well. So there's a Slack invite. There's 2 channels. So we have a job posting for speakers, partners, and sponsors. And this can also be a space where there's a Q&A for hiring managers as well. And we have our events channel. So that's where you guys can continue the discussion after today. And the members of the community will be able to answer any questions that you have after the session that we've had today. Also, the session has been recorded and it'll be available on YouTube after this. So if you want to refer back to any of the links that Gus was mentioning earlier, that can be where you'll find those. So thanks for joining. And if there's no other comments, then yeah, I think that's a wrap.